Question 1. Solve x plus 3 equals 10. To solve an equation, we move all the numbers away from the letter until the letter is on its own. We move numbers by doing the opposite operation to both sides. So we have an x plus 3, we'd want to move the plus 3 to get the letter on its own. So we move that plus 3 by doing the opposite operation. The opposite of a plus is a minus, to both sides. So the opposite of plus 3 is minus 3, so we've done that to both sides. So on the left hand side, the plus 3 and the minus 3 cancel each other out, leaving us with the letter on its own, which is what we want. So the left hand side is an x, and we just calculate the right hand side. 10 minus 3 equals 7. So our final answer there, x equals 7. Question 2. Solve b minus 5 equals 3. To solve an equation, we move all the numbers away from the letter until the letter is on its own. We move numbers by doing the opposite operation to both sides. Here we have a b minus 5. To get the letter on its own, we'd need to move the minus 5. To move a minus 5, we need to do the opposite, which is plus 5 to both sides. On the left hand side, a minus 5 and a plus 5 will cancel each other out, leaving us with the letter on its own, b, and that's what we want. On the right hand side, we just calculate the result. 3 plus 5 equals 8. Final answer, b equals 8. Question 3. Solve 3x equals 12. Once again, to solve an equation, we move all the numbers away from the letter until the letter's on its own. We move numbers by doing the opposite operation to both sides. Now the 3 is beside the x, and in algebra terms it's multiplying by the x. So the opposite operation of a 3 times is a divide by 3. So to move that 3 that's multiplying, we'll need to divide by 3 on both sides. So if we divide by 3, that'll cancel each other out with the multiply by 3, leaving x on its own on the left hand side, which is perfect. And 12 divided by 3 on the right hand side, that's just 4 for the answer there. So the final answer, x equals 4. Question 4. Solve d over 3 equals 5. Remember, to solve an equation, we move all the numbers away from the letter until the letter's on its own. We move numbers by doing the opposite operation to both sides. Now that 3, being on the bottom or underneath the D, is actually dividing into the D. And so the opposite of a dividing 3 is a multiplying by 3. So we're going to multiply by 3 on both sides. A divide by 3 and a multiply by 3 will cancel each other out nicely, and that'll leave us with D on its own on the left hand side. Perfect. On the right hand side we just go with whatever results there. 5 times 3 is 15. So final answer there, D equals 15. Question 5. Solve 3x minus 6 equals 12. Okay, we move all the numbers away from the letter until the letter's on its own. We move numbers by doing the opposite operation to both sides. Now we have two choices here. We need to move either the 3 or the minus 6 first. And here's a guiding principle. We usually move plus or minus numbers before multiply or divide numbers. Not always, but usually. So we're going to move the minus 6 before we think about moving the 3 in this case. Now the opposite of, to move a minus 6, we do the opposite, which is plus 6 to both sides. We'll do that first. Now the minus 6 and the plus 6 cancel out, but we've still got a 3x on the left hand side. And the right hand side, we just go with whatever results there and calculate it. 12 plus 6 equals 18. And now 3 is multiplying by the x. We want to get the letter on its own. The opposite of a times by 3 is a divide by 3 both sides. That will cancel out the 3's and leave us with x on its own on the left hand side, and 18 divided by 3 is 6. Final answer. That's called a two-step equation, so we had to decide which thing to do first, and in this case we moved the minus 6 first. Question 6. Solve y over 3 plus 7 equals 11. We move all the numbers away from the letter until the letter's on its own. We move numbers by doing the opposite operation to both sides. And here we've got two things happening, so we have to remember that we usually move plus or minus numbers before multiply or divide type numbers. So here we're going to choose to act and move on the move the plus 7 before we worry about the 3. So to move a plus 7 we need to do the opposite to both sides. The opposite of a plus 7 is a minus 7 both sides. That will cancel out the 7's nicely on the left hand side, leaving us with y over 3 on the left hand side. And 11 minus 7 is just calculated there, and that'll be a 4. Now the 3 that's underneath, the 3 is dividing into the y there. So to move it, we've got to do the opposite. The opposite of a dividing by 3 is a multiplying by 3. So the 3's will cancel nicely on the left hand side, leaving us with y on its own. And the calculation on the right hand side is just whatever it is. 4 times 3 in this case makes 12. So once again, a two-step equation. We've chosen to move the plus or minus number first before the multiply or divide number. Question 7. Solve k plus 2 all over 6 equals 4. Alrighty, we move all the numbers away from the letter until the letter's on its own. We move numbers by doing the opposite operation to both sides. Now here's an interesting one, this one. Notice how we've got k plus 2 all over 6. Both the k and the 2 are tied up by the 6. And so we usually move plus or minus numbers before multiply or divide numbers, but when we have a long fraction line like we have here, we must move the bottom number first. So we must move the divided by 6 number there first before we can move the 2. So to move the dividing 6 there, we'll need to do the opposite, which is multiplying by 6 both sides. So that'll take care of the 6 that's dividing there and leave us with just k plus 2 on the left hand side. And on the right hand side, 4 times 6 is 24. Simplifies nicely here. All we have to do is move the plus 2 by doing the opposite. Minus 2 both sides, leaving us with k on its own nicely on the left. And 24 minus 2 equals 22 on the right hand side. So k equals 22. So that was a bit of a new one for us. When a number is dividing into the whole of the rest of it, so it's got a long fraction line there, we must move the number on the bottom first before we do anything else. Question 8. Solve x minus 5 all over 4 equals 6. We move all the numbers away from the letter until the letter's on its own. We move numbers by doing the opposite operation to both sides, and we usually move plus or minus numbers before multiply or divide numbers. Now I say we usually move plus or minus numbers before multiply or divide numbers, but when there's a long fraction line, and we have another one here, we must move the bottom number first. So it's a 4 that's dividing, so we'll multiply by a 4 on both sides to move that bottom number first, like we need to with long fraction lines. A divide by 4 and a multiply by 4 cancel each other out nicely, leaving us with just the top. X minus 5 equals 6 times 4 makes 24. And then we'll try and move the minus 5 by doing the opposite of that, which is plus 5 both sides. Left hand side cancels out nicely, leaving us with the x, which is what we wanted, and the calculation on the right hand side there is 24 plus 5 is 29. So once again we've chosen to move a multiplying or dividing type number, in this case a divide by 4 number first. When we have a long fraction line, we must do that first. Question 9. Solve 4 outside of m plus 5 equals 80. We'll expand the brackets first, then we'll solve the equation normally. To expand the brackets, we multiply the front number by the first inside number and get an answer, in this case 4m. Then we'll multiply the front number by the second inside number and get an answer for that, and get 20. We've got to keep those two answers separate, we don't want to merge them together. And that equals 80. So once we've done that expansion there, we've gotten rid of the brackets, and we can just solve the equation normally by moving the numbers away from the letter until the letter's on its own. We move numbers by doing the opposite operation to both sides. And we usually move plus or minus numbers before we move any multiply or divide numbers. So we have a plus 20 that we could move, or a 4 that's multiplying. We're going to move the plus 20 number first by doing the opposite of that. So we'll minus 20 both sides. The plus 20 and the minus 20 cancel each other out nicely, leaving us with 4m on the left hand side. And 80 minus 20, we'll just do that calculation, and that's a 60 for the right hand side. And we just need to move the 4 that's multiplying now to get the letter totally on its own. We'll do the opposite of multiplying by 4, which is dividing by 4 both sides. The multiply by 4 and the divide by 4 cancel each other out, leaving the m on its own. And 60 divided by 4 on the right hand side is 15. So a fair bit happening there, but you'll notice that we expanded the brackets first, and then we had a normal two-step equation. Question 10. Solve 3 outside of x minus 7 equals 36. We're going to expand the brackets first, then we'll solve the equation normally. So to expand the bracket, we'll do the front number by the first term and get an answer. In this case, 3 times x is 3x. Then we'll take the front number and multiply it by the second term in the brackets and get an answer for that. We'll have to be careful here. 3 times minus 7 is minus 21, and that equals 36. Then we've got a normal two-step equation to solve. We move all the numbers away from the letter until the letter's on its own. We move numbers by doing the opposite operation to both sides. And we usually move a plus or minus number before a multiply or divide number. So we'll choose to move the minus 21 with a plus 21 both sides. That'll leave us with 3x on the left hand side and 57 on the right hand side. To move the 3 that's multiplying, we'll do the opposite to both sides. We'll divide by 3 both sides. The 3's will cancel nicely on the left, leaving us with x, and 57 divided by 3 is 19 on the right hand side. So once again, we've expanded the brackets first and then solved a two-step equation in the normal way.